Good morning, students. Can y'all hear me? And can y'all see my screen?
Yes, madam.
Yes, madam.
Okay, right. So welcome to the module STAT 31513. So here we are talking about statistical models. So before we begin with the contents of the module, I want to go through what we are going to discuss in this module and how are we going to evaluate you, right? So I think you can see the module descriptor now. So basically we are going to discuss about the regression models. So starting from the simple linear regression, we are going to discuss the multiple linear regression models, and also we are going to discuss various design techniques, right? When you are given with the data set, how to apply various design techniques to evaluate your data set. So you can see, if you look at the assessment criteria, from the final examination, I'm going to take 70%. And in this module, I'll be giving you assignments and tutorials. So if you just have a look on the Cal page, you would have seen I have already uploaded the first assignment for you. So I will give you a timeline so you can submit the assignment and tutorials. Both assignment and tutorials will be discussed by the demonstrator. So you have to submit them in advance before discussing. So I'll be taking marks from that assignments and tutorials. Apart from that, like if we were conducting this lecture series physically, you'll be getting a mid-day examination. But since we are having this online platform, I will let you know whether you're going to have a spot exam or online in-class test, right? Anyway, you will get one of those in order to evaluate you. So from the assignments, tutorials, and from the in-class test, or the spot exam, I'll be taking the 30%, right? So if you look at the module descriptor, you have the reference books. So you can just have a look. If you have any doubt, right, you can just go through these reference books as well. Okay. And also, since you are in third year, I'm going to conduct lectures all in English medium, right? But if you have any concern, if anything is not clear, you can always ask me. I'm happy to explain you in Sinhala medium as well. But throughout the lecture, I'll be explaining in English. But don't hesitate if you have anything to ask. Okay. So is that clear?
Yes, madam.
Right. So I will share you the content. Right. So this is, we can start the first lesson today. So basically, I'm going to discuss an introduction to linear models today. So have you heard the word linear models before? Have you done anything regarding linear models? I think when you're doing the fundamentals of statistics in your first year, you might have get a small introduction about linear models, right? So here what we are going to do is, when it comes to a linear model, again, it's a parametric model, right? Or in other words, you have an equation where you have one or more response variables and one or more predictor variables, right? So what we are going to do is, when we want to predict something using some other variables, we are using these techniques, which are known as linear models, right? To get accurate answers to a given question. Now, for an example, if you take, I have given you 3 examples. Now, let's say someone is suffering from fever, and if you can find out whether that person, when the person is having fever, you can also see muscle achings, chest rattle, or if you can see all these symptoms, and if you have a database of people who are suffering from fever with these symptoms, we can probably we can come up with an equation, right, uh, to predict the flu with the use of these symptoms. Or else, let's say if you look at the second example, now let's say a farmer is using different kind of fertilizers, right, to different kind of plots. So if we want to check the variation in the growth of crops, we can just use these techniques in order to evaluate that. Okay. And also, if you look at the last example, that is, a person is interested in finding out whether the weight of a newborn baby changes with the length of the first 20 weeks after the birth. So we know if we take the weight of newborn babies, it's vary. You will get different weights. So if you want to find out whether there is a relationship between the weight of the newborn babies with the length of for the first 20 weeks after birth, if you have those two variables, we can probably come up with the equation and find parametric model. So that's what we do in this linear model. So when it comes to linear models, basically we have two types of variables. We have dependent variables, and then we have predictor variables. So if you look at the last example in this case, so if we want to find out the relationship between birth weight and the length of the baby. So we are interested about the birth weight. We want to predict the birth weight. So in that case, our dependent variable, or in other case, your Y variable would be birth weight. And we are going to predict that using the length of the baby. So length would be your predictor variable, right? In other words, your X variable. So to these X variables, in some cases you will have so many X variables. In some cases you will have only one X variable, or you will have only two X variables. Same with the Y variable, the dependent variable. Sometimes you will have only one dependent variable, sometimes you will have more than one, right? So for the X variables, you can call them as predictors because we are using those to predict Y, or you can call them explanatory variables or independent variables, right? So when you change these X variables, with the change of the X variables, we are going to predict Y. So that's why we call the Y as the dependent variable. It's depending on the values of your X, right? But X values, they are independent. Like for an example, if you change the length of the baby, the birth weight might change. But if you change the birth weight, we can't change the length of the baby, right? So in that case, we call the dependent variable is the birth weight, independent variable is the length. So when it comes to regression analysis, the first and foremost thing is the first thing that we are going to discuss here is when you have only one independent variable and when you have only one dependent variable, how to come up with the model, right? That is, you have one X and one Y. So when you are given with the data set, the first thing that we have to do is we need to find out whether there is a relationship between the given two variables. So the basic thing that we can do is we can just plot a scatter plot. So the scatter plot, I'm sure that you have discussed that in your first year. So what we do is we take one variable to your x-axis and the other variable to your y-axis and just plot the coordinates. So as for an example, you can see here, you can see a series of graphs. So when you plot your data set, you will get different uh, graphs, right? So if you look at the first graph, if you look at that, you can see all the data points. If you try to join all the data points, in this case, all the data points would fall on one straight line, right? So that is a perfect case. So in that case, if you look at the first graph and if you look at the last graph, in both cases, if you try to join the points using one straight line, you can see there are no deviations. All the points or all the data points in your graph, you can join using one straight line. So these are perfect cases. So if you have a scatter plot like this, right, that is between your two variables, you have a perfect linear relationship, but actually that is not the case in most of the real life situations, right? But in most of the real life situation, what will happen is when you plot your data set using a scatter plot, you will see your data points will be scattered in your graph, right? They will go here and there. Like if you check this graph, which is in the middle of the two graphs in either sides, so you will see one of these patterns with your data set. So what we can do is at the first glance, if we want to check whether there is any kind of relationship between these two variables, we can calculate the correlation coefficient. So when you're learning about correlation coefficient, now you will learn different kinds of correlations in the future. So since we are interested about the linear relationships, the correlation coefficient that we are going to calculate here is known as the Pearson correlation coefficient. අපි සරල රේඛීය සම්බන්ධතා ගැන තමයි මෙතෙන්දි ගොඩක් අපි බලන්නේ. ඒක නිසා අපි මේ correlation එකට කියන්නේ Pearson correlation coefficient එක කියලා. So in this case, if you calculate the Pearson correlation coefficient, you will get different values. So if you look at the first graph and the last graph where you have the perfect relationships, you can see the Pearson correlation value in the first graph, it is -1, and in the last one, it is +1. So the correlation coefficient, it is varying from -1 to +1. We denoted it by simple R. And if you have a positive slope value in your graph, you will get the correlation as positive. You can see in the last graph, you have a positive slope because the angle between the x-axis, right, it is less than 90 degrees. So we have a positive value for the slope. So your correlation is also positive. And if you look at the first graph, there you have a negative slope. So you have the correlation negative, right? Since these two are the perfect cases, you can take the correlation as equal to 1. And if you look at the middle cases, they are not the perfect values. So in that case, we cannot say the correlation is 0.8, correlation is 0.7. You have to take your data set, you have to calculate and see what is the correlation value. But in that case, you can just, by looking at the slope of your graph, you can just say whether the correlation is positive or negative. For an example, if you look at this second graph, you can see if you try to connect these points using a straight line, you can't connect all the points using one straight line. But if you look at the slope, it will have a negative slope, right? Your straight line would fall something like this. So that's why it's having a negative value for the correlation. right? And here in this graph, you can see it's having a positive slope if you try to join them using a straight line. That's why the correlation is positive. But these values, you cannot say that it's just zero 0.8 or zero 0.4 or whatever. We have to calculate and have a look at the value. Okay, so in this case, in the middle graph, it says the correlation is equal to 0. What does that mean? Does that indicate that there is no relationship between these two variables? What do you think? Now we are interested about finding the relationship. So if it is plus or minus 1, that is we are having a perfect relationship between the two variables, right? If it is 0, what do you think? You think there is no relationship or there is any other interpretation? Correlation එක බිඳුවයි නම් relationship එකක් නැද්ද? නැත්නම් වෙන මොකක් හරි relationship එකක් තියෙනවද? What do you think? Yeah, so there is no linear relationship, but we never know there can be a non-linear relationship between the two variables. But only thing we can say is there is no linear relationship. So you can see this is the equation that we are using to calculate the correlation coefficient, right? So I will go through with an example at the end. So using this equation, we can calculate the correlation coefficient. So now let's say for an example, if you get a value which is close to 1, let's say you get 0.89, then it's a positive value. So we can say when you interpret the relationship, that is a strong positive linear relationship. So if you get a value, let's say if you get minus 0.4, it's not that close to it's not that close to 1, and it is negative. In that case, you can say it is a moderate negative linear relationship. So likewise, we can interpret the correlation value. So more it's close to plus or minus 1, the stronger your linear relationship between the two variables. But the thing is, when you calculate the correlation, we can check whether there is a relationship between your two variables, but it will not give the causation. That is, for an example, if you just check the relationship between alarm clock ringing and the daybreak, right? You will see that there is a relationship between the alarm clock ringing and daybreak, but you cannot say what is the cause, like the alarm clock ringing is due to daybreak or daybreak is happening because of alarm clock ringing. You can't interpret like that just with the use of the correlation. The only thing that we can say is there is a linear relationship and the strength is this, right? So this is where we use the linear regression or regression analysis when we want to find out the causation or the cause in between the variables, right? Because the correlation gives you only the association, only the linear relationship between the two variables. If you want to find out the causes, and when you want to predict your variable with the use of causes, then we have to take the use of regression analysis. So as I told you in the beginning, you have two types of regression analysis, regression techniques. So you have the simple linear regression where you have only one predictor variable. That is, you have only y variable in your equation. And then you have multiple linear regression where you have, you have only one x variable in simple linear regression. And when it comes to multiple linear regression, you have more than one predictor variables. That is, you have so many x variables, right? So if you are going to predict the birth weight using the length of the baby, so our dependent variable birth weight, and we are going to predict that using the length. So x is length. You have 1y, 1x. So that is a simple linear regression, right? But if you are going to predict the fever using the symptoms of that patient, right? In that case, you have so many x variables where it goes to multiple linear regression, right? So why we use this regression analysis? There are different reasons, but as I explained you, the main reason is when we want to find out the effect of the causes in between the variables, we go to regression analysis rather than using the correlation, right? So we can obtain an equation to describe the response variable as a function of predictor variables to forecast, right? When you have your x's and when you have your y variable, when you want to predict your y variable using the regression analysis, we can come up with an equation. So that will give, when you know the values of your x variables, we can predict the y variable, right? And to determine a set of important explanatory variables in describing observed variation in the response variable. So with the x variables, we can just check the variation of y, how your response variable is changing when it comes to regression analysis, and also to compare the relationship between the variables over several sets of data. So when you have different sets of data, you can just fit regression models to different sets of data, and then you can compare them, right? So this is why we use regression analysis. So when it comes to regression analysis, the first thing that you have to do is, first you have to identify your problem, right? What we are going to do here, why we are going to use regression analysis, why can't we stop after calculating correlation coefficient? So those things, first you have to identify your problem, and then you have to identify what is your x variable and what is your y variable, what is the response, what am I going to take as my predictor variable, right? And then if it is, when it comes to the real world situations, then you have to collect your data, and using your data we can fit a model, right? Actually at the beginning we can fit different models, and then after fitting the model, we can check for the validity of the model using the model diagnostic techniques, right? And then finally, when we come up with the best model, then we are ready to predict or forecast the values for the response variable, right? So when it comes to the uses of the regression models, you can see here, you have, it can be used as predictors to predict the values of response variable when the values of explanatory variables are given. That is, now here we are basically talking about the simple linear regression. So here we are going to come up with the equation where we are going to predict the value of y's, that is your response variable, using the values of x. So we are coming up with an equation. So if you know the x values, you can substitute them to the equation and find out the value of y, right? And then you can estimate, this can be used to estimate and describe the characteristics of the response variable. You can see how your response variable is changing using your equation. So we can use our fitted model to explain the variations of your response variable. And also it can be used for controlling purposes, because now when we come up with an equation, we know the exact relationship between x and y's. So if we want to have a specific value for your response variable y, then we can actually control your x variables, and then we can come up with that y variable. For an example, let's say your y variable is the growth of crops. So let's say in a certain farm, this growth of crops is depending on, let's say, rainfall, temperature, and amount of fertilizers that you are going to add. So if if the growth of crops are depending on these three values, what you can do is, if we want to have a particular, let's say we in this season we want to have 1 metric ton of whatever the crops. So if you want to have 1 metric ton, since we know the equation between the growth of crops and these fertilizers, temperature and rainfall, then we can control, let's say we are having a greenhouse, so we can control the temperature, rainfall and the amount of fertilizer that we are going to put to obtain that amount of yield, right? So likewise, we can control our x variables and get what we want from our response variable. So those are the uses of the regression. So here we are going to actually talk about the simple linear regression, as I told you. So in that case, you have only one x variable to predict your response variable, which is the very simplest case in regression analysis. So in this case, now for an example, when it comes to whatever the regression analysis, in order to check the behavior of our data set, the first technique is we have to plot our data set and see, right? So now let's say when you have a data set to fit a simple linear regression model, the first thing you have to do is you have to identify your x variable and your y variable, and then you have to draw a scatter plot, right? Now you can see I have just taken a data set and I have drawn the scatter plot here, and you can see my points, data points of the scatter plots, they are scattered here and there. If I try to join them using one straight line, I can't, right? So in this case, I can join these points using different straight lines. For an example, I can join these 3 dots using one straight line, or if I want, I can draw straight line somewhere here. So from person to person, if I give you the same graph to all of you and ask you to draw a straight line by joining these points on the graph, I will get different answers. But in this case, what we are going to do is we are going to find the best line which will join the maximum number of points and which will describe the given data set accurately. So to find that best line using the given data set, we are using the least square method, right? So we are going to discuss about the least square method. That is how to find your, when you are given with a data set, that is when you have a set of x variable, when you have a data set with one x variable and with one y variable. And if you are asked to fit a simple linear regression, we can use this least square method to come up with an equation, right? So the least square method is the best method because it will give you the best fitted line in simple linear regression, right? So is that clear for y'all up to that point? Any questions? If you have any question, you can raise. Okay, I hope it's clear. So up to now, what we have discussed is about what is correlation, and then why we are coming to regression analysis from correlation. That is, we can't find the causation, and then the why we are using regression analysis, the advantages, and the difference between the simple linear regression and multiple linear regression. So now we are going to find the best fitted line for the simple linear regression using the least square method, right? So as I told you, the least square method is the one which gives you the best fitted model. So it's like this. Now, if you look at this data set, now let's say when I draw a straight line to this data set by joining maximum number of points, let's say it looks like this. So if you look at this graph, you can see, if you look at this first data point, with the graph and the first data point, there is a gap. There is a deviation between this graph and this first data point. But if you look at the second data point, it lies exactly on the graph. There is no gap. So likewise, if you look at all the data points on the graph, some data points may lie exactly on the graph, and in some data points they are deviating from the graph. So this the difference between your fitted graph and your actual data point, we call it as an error. Okay, so what we do in least square method is we are going to find a line which fitted your data points best, where it will minimize this error. Okay, so that is how we are going to find the model equation in the simple linear regression. It will give you, the least square method will give you the best fitted line, where the errors, where it will also minimize the errors of your data set, right? අපේ data set එකේ අපි fit කරපු line එකයි සමහර points උයි අතර gaps තියෙනවා. ඒක අපි කියනවා error එකක් කියලා. ඔයගොල්ලෝ පළවෙනි මේ point එක ගත්තොත් මේක නම් line එක, ඒක අතර gap එකක් තියෙනවා. ඒක තමයි error එක. ඒතර least square method එකෙන් කරන්නේ මේ error එක අඩුම වෙන විදිහට තමයි අපිට line එක fit කරලා දෙන්නේ. So in this case, if you look at this straight line, you can see it's just a straight line. So if we come up with the equation, we know the equation of the straight line, it's equal to y equal mx plus c. So same thing that we can use, we have a y variable, which is our response y. And in the regression analysis, the slope and the intercept, right? The intercept we denote by beta naught, and the slope we denote by beta 1. So you can come up with the regression model that is y equal beta naught plus beta 1x. And at the same time, since there is an error with some of the data points, sometimes error is 0 and sometimes there is an error, right? For an example, in the second data points, there is no error. So in that case, you can take the error as 0. But if you take this distance as plus, let's say it's plus 0.1. And then if you look at the third point, there is again error. We can take it as minus, let's say, minus 0.01. So for some data points, some observations, you have an error. So that error also we have to include in the model. So that is, we have denoted by this epsilon. So you have the model equation in simple linear regression, the relationship between y and x as y equal beta naught plus beta 1 x plus epsilon. Right? So this is the model equation that we are going to use in simple linear regression. Now, if we want to find this equation, if we want to find this model, so in other words, we have to find what is the beta naught value, but what is the beta 1 value with the use of your data set, right? And also the error. So in least square method, what we are going to do is we are going to minimize this error value and we are going to find out the respective beta naught and beta 1 value with the use of your data set, right? So if you look at the first observation, this one, right? So for each and every observation, you can use your model equation and write your and using the model, you can write your observation using the model equation. And if you look at this model equation, you can see I have used capital letters, that is y equal beta naught plus beta 1 capital X plus epsilon. This is very, very important because if I ask you to write the model equation, you have to use capital letters. Why? Here you are using the variables. Here y is a variable, x is a variable. So you have to use capital X and capital Y. But if I ask you to write down, let's say, ith observation using the model equation, you are writing a particular value. So a particular value of X and Y. So in that case, you have to use the simple letter. So that's why here, if you generalize this formula to write down the ith observation, you can write yi is equal beta naught plus beta 1 xi plus epsilon I. So if let's imagine we have n number of data points in our data set. So for each and every data point, we can write down this equation. So yi is the ith value of the response variable and xi is the ith value of the predictor variable and the respective error is given by epsilon I. අපි model equation එක ලියනකොට ඔයගොල්ලෝ හැමතිස්සෙම use කරන්න ඕනේ capital letters and that is the same as in the exam. So if I ask you to write the model equation and if you have written that using simple letters, you will get 0 marks because you will understand when you go to higher studies that will really matter, right? model equation එක ලියන්න කිව්වොත් ඔයගොල්ලෝ xy කියන variables වලට fit කරන model එක තමයි ලියන්නේ. එතකොට ඔයගොල්ලෝ capital letters තමයි අපි variables හැමතිස්සෙම capital letters වලින් පාවිච්චි කරන නිසා ඔයගොල්ලෝ capital letters use කරලා තමයි variables ලියන්න ඕනේ. හැබැයි I වෙනි observation එකට අදාළ model value එක හොයනවා නම් I වෙනි observation එකේ xi ට අදාළ value එකකුත් තියෙනවා yi ට අදාළ value එකකුත් තියෙනවා. එතකොට ඔගොල්ලෝ ලියන්න ඕනේ yi සමාන වෙනවා beta naught plus beta 1 x ගේ xi කියන එක්කෙනාව තමයි මෙතෙන්ට ආදේශ කරන්න ඕනේ. එතකොට ඒකයි යා සිම්පල් වෙලා තියෙන්නේ. මේ error එකේ ith observation එකට අදාළ error එකයි අපි මෙතෙන්ට ආදේශ කරන්නේ. So you have all the simple letters in there. Now what we are going to do is we are going to find out the beta naught and the beta 1 value using the given data set, right? So what we are going to do is now here we have the model equation and then we have the equation for the ith observation, right? So in this case, if you look at this error form, that is epsilon I, if I want, I can write a statement using the same equation for the error, right? So if you just write the error form, if you write an equation for the error, just I can take this error term to my left hand side, and then I can take this response variable to my right hand side, right? So then if you write an equation to the error form, you will get epsilon I is equal to yi minus beta naught plus beta 1 xi. So that is, if you substitute, let's say, if you are interested in finding the epsilon 1, so you can substitute y1 minus beta naught plus beta 1 x1. Then you can find the value of the first error term. මං error එකට මම මෙතන සමීකරණයක් ලිව්වොත් error term එක ලියන්නේ epsilon I කියන එක සමාන වෙනවා yi ගෙන් beta naught plus beta 1 xi කියන එක අඩු වෙනවා. නම් පළවෙනි error එක කීයද කියලා බැලුවොත් මට x1 උයි y1 උයි ආදේශ කරොත් epsilon 1 කියන පළවෙනි error එක එනවා. So likewise you can find out all the error terms one by one. So in the least square method, what we are going to do is we take the error terms and we square it. So this is the error term yi minus beta naught minus beta 1 xi, and then we square it, and then we take the summation of these errors, right? And then we have to minimize this summation of these errors as much as we can. And then at that point, we have to find the value of the beta naught and beta 1, right? අපි කරන්නේ අපි මේ errors අරගෙන errors වල squared value එක පුළුවන් තරම් අඩු වෙන අවස්ථාවේ ඊට අදාළ beta naught උයි beta 1 උයි හොයන එක තමයි least square method එකේදී කරන්නේ. So you have the equation for the error, you have the squared summation of the errors, and we want to minimize this squared summation as much as possible because we want to keep it as much as close to zero, because when there is an error, we don't like that. That's a bias. So we want to keep it as close as to zero. And then we have to find the beta naught and beta 1 value at that point where it gives the minimum squared summation of errors. So how are you going to minimize this squared summation? What is the technique that you can use? මෙතන තියෙන errors වල squared summation එක errors වල වර්ගයන්ගේ එකතුව අඩුම වෙන විදිහට beta naught beta 1 හොයන්න නම් ඕගොල්ලෝ මොකක්ද use කරන technique එක? I know you still didn't have your breakfast, but you can talk. Anyone? Okay, right. So what we have to do is, in order to minimize your squared errors, the squared summation, we can partially differentiate this equation by our two parameters, that is beta naught and beta 1. Right? We take the equation and then we partially differentiate our equation using beta naught and beta 1, because then the error will be minimized and at the same time we will get the respective beta naught and beta 1 values. අපේ මේ errors වල squared summation එක අඩුම කරන්න නම් ඒ අඩුම වෙන අවස්ථාවේ beta naught beta 1 නම් අපි හොයාගන්න ඕන. අපේ parameters දෙකක් තියෙන නිසා equation එකේ beta naught beta 1 කියලා අපිට පුළුවන් ආංශික අවකලනය කරන්න. කරලා අදාළ beta naught beta 1 හොයාගන්න පුළුවන්. We can partially differentiate and take the two equations, and then we can equal those two equations to 0 and find out the respective beta naught and beta 1 values. Okay, so if you take the first equation, first you can partially differentiate using beta naught, right? And then you can equal the value to 0, then you will come up with one equation. Then you can take the same equation, partially differentiate it by beta 1, and then you can come up with the second equation. So you can see, if you look at the first one, when you partially differentiate with the beta naught, you have only minus sign, and here you have a squared value. So it's 2 times you take this term and multiply by minus 1, you can equal that is to 0. And if you partially differentiate this by beta 1, you can, again you have the squared term, so 2 times this term, and then you have minus xi, right? Minus xi, so you can equal that to 0. So you can very easily solve these two equations, and then once you solve these two equations, you will get a value for beta 1 and beta naught. Okay, so you can see, for the beta 1, you can come up with this equation, that is, you have summation xi minus x bar into yi minus y bar divided by summation xi minus x bar squared. So as for the notations, this numerator term we can write as xxy, and then for the denominator term, since you have the difference between the x variables, right, so you write it as sxx, and the beta naught you write it as y bar minus beta 1 hat x bar. So you can see in this case, if you look at the equation, I have used beta 1 hat, and here I have used beta naught hat. It's not just beta 1 and beta naught. Why? What we are going to do is, when you are given with the data set, when you just apply this equation to the data set, you will get a value. Let's say it's 2.5. So that is the value for your parameter beta 1. So beta 1 is the parameter, but when you find a value for that particular parameter, right, it's a changing value based on your data set. So then we call it as an estimate, right? When you take it as just a general value, you here first we are going they are the estimators, but when you find a particular value based on your data set, we call it as an estimate, right? අපේ ඔගොල්ලෝ data set එකට අදාළ beta 1 value එකක් හොයාගත්තොත් අපි එකට කියන්නේ estimate එකක් කියලා. ඒක data set එකෙන් data set එකට වෙනස් වෙනවා. So when you apply this equation, you get a particular value, right? That's why we call it as an estimate. So the estimates are denoted by this hat notation, right? So that's why you have to use this beta 1 hat and beta naught hat. So you can see in the beta naught equation, that is equal to y bar minus beta 1 hat x bar. Okay, so in this case, what you have to do is you have to find the mean value of y, mean value of x, and beta 1 hat means first you have to find the value of beta 1 using this equation, and that value you have to substitute here. Okay, so then you will get a value for beta 1 and you will get a value for beta naught. So these two equations, how did we get them? By solving these equation 1 and 2. So I have uploaded your assignment 1. So you have to just read your reference books, or if you just search on Google, you will get the proof of this. It's not just writing the proof, you have to get that into your mind and see how the steps are coming, and then you have to find out the proof to these two equations, right? You have to do that for your assignment 1. Okay, so what will happen now, we have a nice equation for the simple linear regression, right? So since we are interested about predicting the values, you can see here I have written here the least square regression line is equal to y hat equal beta naught hat plus beta 1 hat x. So you can't see the epsilon, the error term. Why? In the least square regression, what we did is we tried to minimize the error. And in that case, the error is very close to 0. And when we are predicting the values for y, right, we are taking the best fitted line by omitting the error, right? Because we have minimized the error as much as possible. So since we are writing the fitted line, you can use this hat notation. That is, if you are going to predict a particular value for y, that is denoted by y hat, that is equal to beta naught hat plus beta 1 hat into x. අපි මොකක් හරි අදාළ value එකක් predict කරන නිසා අපි y hat කියලා ලියනවා. Y hat කියන එක සමාන වෙනවා beta naught hat plus beta 1 hat x. එතකොට අපේ error term එක නැති වෙලා තිනා අපි least square method එකෙන් error term එක පුළුවන් තරම් minimize වෙන විදිහට තමයි මේ fitted line එක ගත්තේ. So we can just forget about the error term, right? So we know the error is the difference between your fitted line and your original data point. So as I explained you at the beginning, so if this is the fitted line which gives from the least square method, the error is the difference between these 2 points, the fitted line and the actual observation. So the actual observation is if this is the ith observation, actual observation is yi. From the line you get yi hat. Fitted line එකෙන් හම්බ වෙන value එක yi hat. Actual observation එක yi. So the difference between these 2 points, that is known as the error. So that we can write as yi minus yi hat. Actual observation එකේ fitted observation එකේ වෙනස තමයි අපේ error එක. එහෙනම් fitted එක හම්බ වෙන්නේ yi hat ගෙන් මේ equation එකට ආදේශ කරාම ඕගොල්ලෝ b naught උයි beta naught hat උයි beta 1 hat උයි x value එකයි ආදේශ කරාම ඕගොල්ලන්ට හම්බ වෙනවා y hat value එක. And then if you take the difference between yi and yi hat, you will get the error, right? So if you have like, if you are wondering why we didn't use hat sign for x, right? Here we are not changing x value because we are taking original x values to predict the y. Right, that's why sometimes the y value when we predict also, sometimes we will get the original y, or sometimes it will be a different value. So y is changing, so that's why you have had the fitted value for that, but we are not changing x, we are taking the original value from the data set to predict. That's why we are not using the hat notation for x. Okay, so if you look at this fitted model, if you look at now, when you take your data set, when you take the mean value of the data set, right, that is x bar, y bar, we can show this x bar, y bar, this data point is passing through this fitted line. least square regression එකෙන් දෙන මේ line එකේ උඩ තමයි x bar y bar කියන point එක තියෙන්නේ කියලා අපිට පෙන්වන්න පුළුවන්. So there is a proof for that. So again, you have to refer. So you have some homework to do. You have 1 week time for that. Actually, that is more than enough because since you are in 3rd year and since you are in university, I don't want to spoon feed you all the things. So you have to just refer something and learn by yourself. But if you have any difficulty and if you don't understand anything, please feel free to discuss or ask, right? But these things you have to find out by yourself. And that is you have to do as per your assignment 1. Okay, so the first thing in the assignment is you have to prove the equations, the least square equations by partially differentiating these, and by solving these two equations, you have to come up with the two equations beta 1 hat and beta naught hat. And then you have to show that x bar, y bar, this coordinate or this line passes through this fitted least square regression line. Okay, so those 2 points you have to do as assignment 1. Right, so let's have a look on this example. It says a larger bank is planning to introduce new system to its employees, and management needs to know amount of training time their employees need to adapt to the new system. 8 employees with equal skills were selected, and they were trained for different amount of time. After the training, each employee were engaged in working using the new system for a given task. Following table contains training time and the time. Sorry, I think I got dropped. Can y'all hear me now?
Yes, madam.
Uh, did y'all hear me like up to the point where I started to discuss the example?
Yes, madam.
Okay, right. Give me a second, I'll share. Can you all see, Putta?
Yes, madam.
Okay, right. So we were discussing about the example. So here what has happened is there is a bank, and they are going to introduce a new system. So before introducing this new system, they have like, they are giving a training program to these employees, right? And then they have recorded the training times in hours, and they have asked these employees to perform this task, and the time taken to perform this task is also recorded using hours. So you have two variables, that is your training time and the time taken to complete your task, right? So in this case, we want to check whether there is association between this training time and time taken to complete this task, right? So in this case, if the training time, if the time taken to complete this task is depending on the training time, we can come up with an equation. Okay, so the first thing that you can do in this case, what is your x variable and what is your y variable? What is your x? Is that training time or time taken to complete the task? කවුද x? Training time එකද task එක complete කරන්න යන time එකද? Let's see, we have a message. Okay, right. It's correct. It's the training time is your x variable, and we can take the time taken to complete the task as your y variable. So let's have a look on the questions. So you have to draw the scatter plot and see whether there's a relationship between the two variables, and you have to find the correlation coefficient, and you have to find the best fit line, right? That is using the least square method. You have to find the regression line, and then you draw the fitted regression line on the scatter plot and find out the values of this error, summation of errors, and then you have to interpret all your findings, right? Let's do one by one. Let me share. Okay, so since it's easy for me, I have put all the uh, data values into an Excel sheet, but you will not get an Excel sheet in your exam. And in this course, we'll be using a statistical software to get the output. So you will have a separate session for that. So in your exam, I can give you the outputs and ask questions as well. So you have to get familiar with the package software that we are going to use as well. And you can use your calculator, but no Excel. But since it's easy to explain, I have just put all my data points to this Excel. So just as you mentioned, the training time is your X variable and time taken to complete the task is your Y variable. So if we are going to complete the correlation coefficient, okay, then in that case we can find, this is the equation that you have to use. First you have to take the difference between your X variable and its mean, difference between your Y variable and its mean, then you have to take the product and get the summation, right? And you whole thing you have to divide by the square root of summation xi minus x bar squared into summation yi minus y bar squared. So first what I have done is I first found the mean value of x. That is, if you take the summation of the x's, that is 155, the summation of these values. And since you have 8, you have to divide it by 8, then you get 19.375. And if you get the summation of y values, that is 150.5. So since there are 8 values, I divided by 8. So that is 18.8125. It's 2 decimal places would be enough for your calculations in the exam. So now we can calculate the difference between x value and its mean, y value and its mean. So you can see here we are going to calculate the difference between x and its mean. So since it's Excel, it's easy for me, but in the exam you have to do it manually. So you take the x value minus you take the mean value, right? So likewise, you have to calculate the difference between the x and its mean value. Same thing you have to do for y. You take the y value and minus the mean value of y. If you just want to, if you want, I just write it using the number 18.8125. So this difference you have to calculate. That is, from all the y values, you have to subtract the mean. And then you have to take the product of these two. So that is, you take xi minus x bar into yi minus y bar. And then you take this product. And then you have to take the summation of this product, right? So since it's Excel, easy for me to take the summation. You just take the summation of this column. So the summation is minus 128.5375. And now we are done with our numerator to calculate the Pearson correlation. So R is equal to, the numerator is equal to this value, minus 128.5375. So we have to calculate the denominator. So in that case, now here you have to calculate the squared value of this x difference. So we have the difference of xy minus x bar. So you have to calculate the squared value of that. So just get the squared value of the x differences. And then you have to get the squared value of the y differences. So we have yi minus y bar value. So you have to get the squared value of that. And then here you have the squared value, and then you have to take the summation, right? So I'm going to get the summation of these squared values. And then we can get the summation of yi minus y bar squared values as well. Okay. So now we are ready to calculate the correlation. So our numerator, we have this one minus 128.5375 divided by, we have to take the square root value. We have to take the square root value of these two, the product of these two, 281.875 into 63.76875. Right. So you can see our Pearson correlation value is minus 0.95873. So if you just have a look at this data set, and if you just plot this data set, you will see actually the when you look at the data set, if you first draw the scatter plot, it looks like this. So you can see if you try to join these points using a straight line, whatever the line that you draw, it has a negative slope value. That's why your correlation is negative, and it's very close to 1. So in this case, we are having a strong negative linear relationship between the training time and time taken to complete the task. Okay, so this is how you find out the correlation and interpret that. And now we can also find out the beta 1 hat and beta naught hat value to come up with the model equation. So if you check the beta 1 hat value, so if you check the numerator, we have xi minus x bar into yi minus y bar, the summation of this product, same as the correlation, the same numerator you have. If you look at the denominator, we have xi minus x bar squared summation. So we have xi minus x bar squared values and the summation as well. So the beta 1 hat, I'm going to calculate here. So this is the summation of the product. We have to divide it by xi minus x bar squared summation. So that is minus 0.456 beta 1. So now we can find out beta naught as well. So beta naught is equal to y bar value. So y bar we calculated at the beginning. That is 18.8125 and minus. So we have the beta 1 hat value, this one, into x bar value. So beta naught we have, it is 27.647, right? So in this case, I can write the model equation, right? So I can write the model equation, that is y is equal to beta naught is 27 point, let's take it as for 2 decimals, 65 minus beta 1 value is 0.46 into x. So this is the model equation. You can just write here y hat as y hat. Okay, this is the y hat value. Y hat value is equal to 27.65 minus 0.46 times x. So this is the model equation that we come up with the use of least square regression, right? So how can you interpret these two parameters? Now, if you take the beta 1 value, where it's the slope of your equation, where you have a negative slope here, right? So in the simple linear regression, when you have to interpret the beta 1 value or beta 1 hat or the slope value, that is on average, it will give you the change of y per unit increase in x variable, right? That is, in this case, your x variable is training time, and they have recorded the training time using hours. So that means when the training times is increasing by 1 unit, means when the training time is increasing by 1 hour, on average, the time taken to complete this task will decrease by 0.46 hours, because the time taken to complete the task is also recorded using hours. X සහ Y දෙකම record කරලා තියෙන්නේ hours වලින්. එතකොට අපි beta 1 interpret කරන්නේ on average y ගේ change එක x ඒකකයකින් වැඩි වෙනකොට. එතකොට x hours වලින් තියෙන හින්දා x එක unit එකකින් වැඩි වෙනවා කියන්නේ x එක hour එකකින් වැඩි වෙනවා. training time එක එක hour එකකින් වැඩි වෙනකොට on average මේගොල්ලන්ට මේ task එක complete කරන්න යන වෙලාව 0.46 hours වලින් අඩු වෙනවා. So if you want, you can just check that by converting to minutes, right? So in this case, if I ask you to interpret beta 1, that's how you interpret. That is, when you increase the training time by 1 hour, on average, the time taken to complete this task will decrease by 0.46 hours, right? And then when it comes to beta naught is, we know that is the intercept of the graph, right? In other words, it gives you the value of y when x is equal to 0. Beta naught කියන්නේ intercept එක. අපි දන්නවා x බිඳුව වෙන අවස්ථාවේ y ගේ අගය තමයි දෙන්නේ. So the same way you can interpret, if the time taken, if the training time is equal to 0, that means if you do not give any training to these employees, they will take 27.65 hours to complete this task. X කියන එක බිඳුවයි කියන්නේ training time එක බිඳුවයි. නම් මේ employees ලට training time එකක් training එකක් දුන්නේ නැති වුණොත් ඒගොල්ලන්ට task එක complete කරන්න පැය 27.64ක් යනවා. The important thing is, for every data set, you cannot interpret beta naught. In some data sets you can, but in some data sets you cannot interpret. So in your examination, right, if I ask you to interpret your parameters beta naught and beta 1, if there is no meaning, don't write the interpretation of beta naught. For an example, if your x variable is the length of the baby and if your y variable is the weight, right? In that case, if you try to interpret beta naught, that is when the length of baby is equal to 0, the weight value. So that is not making any sense. දිගක් නැතිව බබෙක්ගේ බරක් ඔයගලන්ට කියන්න බැහැනේ. So in that case, you cannot interpret beta naught value. So don't write the interpretations. You have to use your common sense and check whether there is a meaning for these interpretations or not, right? So likewise, you have to find out the interpretations. And in this case, here they have also asked to find out the error terms. Now, I told you the error is the difference between the original y value and the fitted model. So in this case, if you want to find out the errors, first you have to find the y hat values. How are you going to find the y hat values? Now we know the model equation, right? Now, since we know the model equation, we can find the y hat values. For an example, if you take the first one, here the model is this. Now the first x value is 22. So we can substitute 22 to the model and find out the corresponding y value. That is the y1 hat value. For an example, if you take the first one, that is 27.65 minus, then we have 0.46 into first 0.46 into first x value, that is 22. So we take the first x value and that will give you the predicted y value using the model. Model equation එකට අනුව අපි පළවෙනි x මෙතෙන්ට ආදේශ කරාම හම්බෙන y තමයි පළවෙනි y ට අදාළ predicted y hat. So likewise, you can check all the y hat values here. You take the original x values and substitute to the equation, right, to get the y hat values. But here we are actually interested about the error term. So error is the difference between the original y and y hat values. අපි original data set එකේ තියෙන y සහ අපේ model එකෙන් අපි predict කරන y ගේ අතර වෙනස තමයි y hat කියලා කියන්නේ. So in this case, we have the y hat values we can find, and when you take the difference between the y and y hat values, you will get the errors. You can see sometimes errors are positive and sometimes negative, right? Because they are scattered in the either sides of your fitted line. That's why sometimes they are positive and sometimes they are negative. So in your in the questions, they are asking you to calculate the errors and take the summation of the errors and see. So let's take the summation of these errors. You have to take the total here, right? So that is 0.6. You can see it is, we have fitted the regression line using the least square, where the if you take the squared summation, that will be even smaller value than this, right? So this is how you fit a regression model using the least square method. You have any questions up to that point? Crystal clear? No questions? Okay then. So now what we have to do is, in the simple linear regression, after fitting the regression model, okay, now we're at the beginning, we have a data set, we find out what is x and what is y, we come up with this regression line, and then we have to check whether this is a good regression model, or this model is okay to do the predictions, right? In this case, when we are using these models, actually there are some properties or some assumptions which are related to this regression model. First assumption is your response variable y and your predictor variables, they are linearly related. That's why we are coming up with the linear model, right? අපි හිතනම ඔගොල්ලොන්ගේ තියෙන x variable එකයි y අතරයි තියෙන සරල රේඛීය සම්බන්ධයක් කියලා. එකයි අපි y සමාන mx ධන c ආකාරයේ සමීකරණයකින් අපි මේ model එක fit කරන්නේ. So there is a linear relationship. And also, now when you take these error terms, now we saw how to calculate the errors for each and every observation after fitting the regression line. So if you just take all these error terms, and if you check the mean value of these error terms, that would be equal to 0. ඔගොල්ලෝ මේ errors ටික වෙන වෙනම හොයලා ඒ errors වල mean එක හෙව්වොත් ඕනෙම data set එකක errors වල mean එක 0 වෙනවා. And if you take the variance of these error terms, it's a constant value, right? So what we do is, we one assumption here in simple linear regression is your error terms, they are normally distributed. If you plot the errors, you will see they are normally distributed with zero mean and constant variance. And also these errors are uncorrelated errors, because if you take the first observation and if you take the error term of the second observation, there is no connection. You will get different values. They are independent, right? They are not interrelated, right? So these are the assumptions in simple linear regression. Your y variable and x variables, they are linearly related, and if you take the error terms, they are normally distributed with zero mean and constant variance, and also these errors are independent. There is no relation between these errors. So after fitting the model, What you have to do is we have to actually check whether these assumptions are violating or not. And then only we can decide whether our model is good to forecast. අපේ model එක fit කරාන් පස්සේ අපි මේ assumptions ටික එකකට හරිද කියලා බලනවා. මේ ඔක්කොම හරි නම් තමයි අපේ model එක ready වෙන්නේ predictions were. So I will discuss later in the coming up lectures how to check these assumptions one by one, right? And then also, if you take these estimators that we found using the least square method, right? That is we found for the beta naught parameter from the least square, we can find the value. We denoted that by beta naught hat, and for the beta 1, we denoted by beta 1 hat. So if you take the expected value of this estimated, that is equal to that parameter itself. That is, these estimators are unbiased. අපි මේ හොයාගත්ත beta naught, beta 1 කියන ඒවල values අපි හොයාගත්ත least square method එකෙන් මේ least square method එකෙන් හම්බෙන මේ estimators වල expected value එක ගත්තොත් ඒක ඒ parameter එකටම සමාන වෙනවා. එතකොට අපි කියනවා unbiased parameters කියලා. I think you have discussed that in your first year, right? And here we can show that beta naught hat and beta 1 hat are linear functions of yi. And also, if you take all the unbiased estimators, we can show from the least square method, we get the estimators which have the minimum variance, right? So all these properties of the least square estimators, we can do that. We can show it by a proof. So that also you have to find out. We are discussing all after you submit this assignment, right? So don't worry, just give a try to find out. So if you don't understand, don't worry, we will be discussing the assignment also, right? And if you want to find out the variance of these estimators, the variance is given by sigma squared divided by sxx. So we know what is sxx, that is summation xi minus x bar squared. And we can use this equation to find the variance of beta naught hat, and the covariance is given by this, right? So for the variance also, we can prove it using the equations that we are going to forecast, that we are going to find the value of the beta 1 and beta nodes, right? We at the beginning, by partially differentiating the equations, we have two equations to predict beta naught and beta 1 value. So using those equations, we can show all these properties, right? So these tasks are for you as homework to just have a look and do, and you can submit that to Cal. I think I have given time until 26th July. So you can take your time and submit, and we will discuss the first assignment also after you submit that. Okay. So before that, I will show you another one. Now, in this case, I told you here, if you take the, yeah, so you can see the calculation also to find out the least square estimates, right? So do you have any question up to this point? And in this case, I told you when you take the error terms, these errors are having a zero mean and a constant variance, right? Now, in this case, you can see if you take the summation of the error terms, that is adding up to 0.6. Right? If the mean is equal to 0, this should be 0. No? So this is actually because I have taken up to only 2 decimal places. So it's a value which is close to 0. But if you consider all these decimal places and check, because if you are just considering two decimals, I should have considered two decimals from the beginning. Then this summation would add up to 0, right? That's why. So just do the calculation manually when you are at home, and then you will see the summation is adding up to 0, right? Any questions, students? You understand what I told you today? මං කියන ඒවා තේරෙනවද ඔය ළමයින්ට?
Yes, madam.
නිමතේ නෙමෙයි නේ ආගෙන ඉන්නේ නැත්තේ කට්ටියම. Okay, so if you have anything which is unclear, if you don't feel comfortable to talk here, you can email me, right? So my email address is harshana@kln.ac.lk, right? So don't hesitate, just ask any question you have. Okay, then if you have no questions, we are done for today. We can end the session now. Okay, then I'll see you tomorrow. Have a good day. Thank you. Yeah. One has asked me to upload the recording. Sure, I will upload all the recordings and the materials as well. That will be uploaded to your cat. Thank you.